Hi Chem Squad. In today's class we're going to look at how to write net ionic equations. When we're writing net ionic equations, it's basically a reaction that involves ions. Now in particular, we want to show only the ions that are present in a solution that actually forms a precipitate. Okay? And if you remember from our last video or from our last lesson, precipitate is basically a solid that comes out of solution. Okay, so it's no longer dissolved. Now, any other ions that might still be in solution but do not help in forming the precipitate is said to be a spectator ion. Spectators are just there to observe and watch. They're not actually involved in forming the precipitate. So we often do not include spectator ions in our net ionic equation. So to give you an idea of how to set up a net ionic equation and when to do it, let's look at this example down here. Here I have a beaker, and this beaker is basically a solution that is filled with different ions. Okay, so it can contain many different ions. Let's just choose a few for now. Let's choose lithium ion, Li+. Let's also put in some sulfate ions, SO4 2 negative, some Pb ions, which is basically lead ions, and let's put in a nitrate ion, NO3 negative. So I have 4 different ions, 2 positives, 2 negatives. Only the positive and the negatives can combine to form products. So really, I can have lithium sulfate, I can have lithium nitrate, or I can have lead sulfate or lead nitrate. So of all these different ions, I have 4 different combinations that are possible. I only need the one combination that will form a precipitate. Okay? So in order to figure that out, I'll have to look at my solubility table. So on the solubility table, things are listed in terms of anions first and then cations second. So if we looked at NO3, NO3 is up here. Okay? NO3 nitrate can dissolve with essentially all positive ions, okay, to be soluble. So it's unlikely for my NO3 to actually help form a precipitate. Okay? If I look at Li+, Li+ is up here as part of the alkali ions. They too basically mix with essentially any anion to become soluble. So it's unlikely that my Li will also form a precipitate. So that really leaves us with SO4, and if we look over here, SO4 plus Pb gives you low solubility or insoluble. This means the two combinations, when mixed together, will form a precipitate. So going back to our little diagram here, these two help to form a precipitate. So when they combine, they will form a solid substance at the bottom of our beaker. Okay? These two do nothing. Okay? They're not actually involved in making that precipitate. So our net ionic reaction will tend to look like this. You take the ions that are involved, so in this case Pb2+, because it's an ion, the state that it's in is automatically aqueous. Okay? We're going to add it to a SO4, 2 negative ion, which is again also aqueous. So when these two are combined together, they will form PbSO4 as a solid. Okay, so I double check to see if I need to balance. I have one Pb on both sides, so that seems to be fine. I have one SO4 on both sides, so the SO4s are balanced. I check for charge. +2 and -2 gives me 0. On the product side, I also have neutral charge. So this is my net ionic equation. Pb2+ plus SO4 2 negative to give me my lead to sulfate. The spectator ions are the ones that were present but don't do anything. So in this case, I just list my spectator ions as Li plus and NO3 negative. So here's a really simple example of how you can solve or set up a net ionic equation. Sometimes you might also see it in a different form. So if we go down here in this particular example, okay, I'm giving you a double replacement reaction. Determine the net ionic equation and the spectator ions. So for something like this, it's not clearly spelled out in terms of what your ions are, but you can actually figure it out, okay? Because even in a double replacement reaction, there are only two ways for things to combine. So when we look at calcium hydroxide, the first element is typically a positive. So calcium has a charge of 2 plus. If you look on the backside of your periodic table and you look for complex ions, you will find a charge for the hydroxide ion. The charge is O negative. Okay. NO3 has a charge of -1, and because you have two of them, okay, that must mean that the charge on Cu is a 2 plus. So again, you can figure out all four types of ions that are involved. So in this case here, because it's a double replacement reaction, we know that Ca and NO3 can react together. Okay, that could be a possibility. So Ca bracket NO3 2, okay, that could be a product, a potential product. Cu and OH is also a potential product. So because we have Cu and Cu has a positive 2 charge, we're going to need two sets of hydroxide ions in order to balance out the charge. Okay, so it's going to be Cu bracket OH2. So one of these two actually form a precipitate. So again, we're going to go back to our solubility table, and we're going to find that NO3, again, dissolves with almost any ion, so it's not likely for that one to be a precipitate. So we just double check with OH. OH plus any one of these ions listed are soluble. Our copper ion is not among them. Okay, so copper must be under all others. So that means OH plus copper ions are low soluble. So if they're low soluble, this one here needs to be my precipitate. Okay, so that means when I'm writing out the net ionic, I want to include the ions. So in this case, Cu2 plus, aqueous, plus the OH ions, aqueous, to give us CuOH2 solid. So whenever I'm doing any type of ionic reaction, okay, whether it's net or not, I need to make sure that it is balanced. So I have one copper, one copper. I have one set of OH, but I have two over here. So that's an easy problem to fix. I just have to put a 2, coefficient 2, in front of the OH. Okay, so now I have balanced the atoms, and I've also balanced the charge, because I have a +2 charge and I have two negative charges. That cancels out to neutral. The spectator ions are the ones that were not involved. Okay, they're the ones that actually form CaNO3 2. So I just list off the spectator ions as Ca2 plus and NO3 negative. And that's all I have to do for these net ionic reactions with their spectator ions. Always give me the ions that form the precipitate. Spectator ions are always the ions that are not involved. They're the leftover or left behind ions that do nothing. So hopefully this video has helped you a little bit to understand how to write net ionic reactions. Thank you. See you soon.